All right, I'm bringing it back old school here. We're doing 4.2. This is summation. This was actually 4.2 day 1, well, 4.2 day 2. Summation. This is, I taught this in FST. I don't know if you got any exposure in pre-calc or algebra 2, but this is summation. We have this is called sigma. This is an upper bound. This is an index of summation, or the lower bound. This is A of I, the ith term, and this will say sum up all the answers. Instead of saying A1 plus A2 plus A3 all the way to A sub n, they just use this notation. Pretty easy. You've seen this before. So if I wanted, here, just for the heck of it, if you wanted the average of 3 things, it would be something like this. It would be 1I equals 1 to 3. It's an I. Of some number, you're going to add them up and divide by 3. That's the average. All right, so that's where it's kind of used. It's kind of used to save space and to create sequences and series. So let's do an example of one of these. And I think you've seen this before. I don't know why, but we're going to do the sum as I goes from 1 to 6 of I. Well, that means it's almost like looping itself. I is 1, then I is 2, then I is 3, I is 4, I is 5, and I is 6, and you add all of them up. When you add all of them up, voila, blackjack, 21. Okay, and that means add up all the numbers from 1 to 6, and that's an I. Sometimes these could be different expressions, like the next problem. I don't think you're going to see much calculus here today. You're going to see a lot of recap, all right? I squared plus 2. So what this says is now I'm going to start at 3. Okay, now I'm starting at 3 and going to 7. So when I plug in 3, I get 3 squared plus 2, which is 9 plus 2 is 11. Then I get 4 squared plus 2. You know what? Let me write that. 3 squared plus 2, then 4 plus 4 squared plus 2, plus 5 squared plus 2, etc., plus 6 squared plus 2, plus 7 squared plus 2. All right? You really don't have to do all that work, but you just got to find out that the answer is 145. Good enough? Remember, just keep adding it to itself as many times as you need to. Now here's some important formulas for you. You need to know these because we have, let's talk about this. If I have a constant, sum of a constant, all right, the sum of a constant is equal to the constant times n. Just multiply these two guys together. It's these two babies right here. So if that was 8, it'd be 8 times n because you're going to add 8 n times. The next one is the one, this is the most common one, all right? The sum is 1 to n of I. You could say that's equal to this and get it in terms of n. So you don't have to go through the process of this plus this plus this. There's now a formula that can get you to the answer. Likewise with I squared, likewise with I cubed. There's formulas that can get you to the answer without going this plus this plus this. Like in the last section, just to show you, it was 1I is 1 to 6. Okay? So using this formula here, right here, it would be 6 times 7 divided by 2. 42 divided by 2 is 21. And the answer I got here was 21. So these are formulas, so I don't have to go through all the addition, just dealing with n. Now, I also have highlighted I has to equal 1 here. Okay? It's important. Maybe not right now, but it will be important. So let's do maybe a few. Here's 2 problems. I'm going to do I from 1 to n of I plus 1 over n squared. That's evaluate for n equals 100 and for n equals 10. So let's see what I can do here. All right. N doesn't change. So I would consider this to be a constant, all right? So I would probably take that out of the summation. Then I would be left with this. I plus 1. From I to equal 1. And let's choose 100, because that's the first one we'll do. 100. So let me replace this guy with 100 squared. Makes sense. Okay. Now let's get a formula for what's going on here. This is the same as 100 I equals 1 for I plus, we'll distribute, almost like distributing the sigma, I equals 100 to 1. Well, we learned that this is still 1 over 100 squared times, well, this is n plus 1 all over 2. So that's 100 times 101. Wow. I said 101 and I wrote 100. That's why I'm saying wow. 101 divided by 2. So that's actually 50/50 plus constant times this from that first rule, and that's 100. So we get 50/50 plus 100 divided by 100 squared. And I say 100 squared, and guess what I put? 1,000. However, maybe I want to just multiply it because things will start canceling out here. Watch this. Either way you shake it at the end, this is going to be 5150, good Van Halen album. And this is going to be over 100 times 100. And we could start simplifying this if we want. Whatever it comes out to be, I don't know. I really don't know. Whatever it is, it is. I know you hate when I do that, but something very small. It doesn't make any sense, though. 1 second. I got to think about this. 1 second. It does make sense, and this is 0.515. Now let's do the second problem up here, and that's for 10. So when n equals 10, it's 1 over 10 squared. I'm just going to bring it from almost this point right here, okay? And it's going to be 10 times 11 divided by 2 plus, now this one would be 1 to 10. 1 times 10 is 10, so this would be plus 10. And this is turning out to be, I don't know, what do we have here? This is 65 over 100. I think. Yeah, 65 over 100. That sounds good. So that's like 13/20ths or whatever that turns out to be by decimal. I don't know if you can use calculators or not. I'm on the fence right now with it. Let's do a few more. I got some K's involved. Got a problem. Okay, our first problem here is that this is at 0. So none of those other methods, these formulas up here, always start at 1. So when this starts at 0, I have to go through it. It's going to be equal to 1 over 1 when k is 0, plus 1 over 5, plus, oh, I'm sorry, I missed one. Wow. When k is 0, this is when k is 0. Ah! And when k is 1, it's 1 over 2. When k is 3, it's, I don't know. So when it's 1, it's 1 over 2. When it's 2, I don't know why I don't know how to count today. It's ridiculous. 1 over 5. When k is 3, it's 1 over 10. When k is 4, it's 1 over 17. And if you add all those up, you'll get, because I went to 0 to 4, you get 158 over 85, and whatever that comes out to be. All right, getting common denominators and things of that nature. The next one, I'm going to try and do it a little nicer. I'm going to say that this is 2i. So I'm going to bring the 2 out. Any constant I have, I bring out. All right, and I'm going to try to use those formulas to help me out. and this one's going to be of I. Well, this one I know as a formula is 20 times 21 divided by 2. But wait a minute. That 2 on the outside, this 2 right here, I'm also going to multiply it by. So this 2 and that 2 are going to cancel. So I'm just left with 422, I think it is. I hope. 421 times 20. Hoping 422. Please check it out for me. All right? One more. And I promise you it's one more. It's not two more. All right, Kyrie? So here we go. Example. I don't have it written. But let me write it. The limit. Oh, my God, I'm bringing back limits. Don't get too nervous, but I'm bringing back limits. Limit as n goes to infinity, because sometimes we take these series or sequences and we just keep going and going and going like the Energizer Bunny. And here we go. This is our problem. I'm going to go ahead and I'm going to multiply it out. So I'm going to distribute each one of these. All right. Notice there's no sigma. There's no sigma notation. So if you join a sorority, or it's usually sorority, sigma, sigma, sigma. Okay. Anyway, here we go. What do we get? 8. We get 8/3 on the first one plus 12n squared over 3n cubed plus 4n over 3n cubed. Limit as n goes to infinity. Now, this guy, since it's bottom heavy, goes to 0. That's bottom heavy goes to 0. Answer 8/3. Don't forget your top heavy and bottom heavy things. If it's bottom heavy, it's 0. If it's top heavy, it's infinity. If it's top heavy, you can't really do it. All right. You might say, well, where are we going with this stuff? Well, we're going to start looking at area under curves, and we're going to do it by summing up rectangles. Okay, we're going to get an area under a curve, we're going to get equal rectangles, and we're going to sum them up. That's where the sum comes from. For homework or for classwork, you're going to do some problems involving these. I'm breaking them up to these 4 different things. If you want to know, I would like you to try, for homework, I would like you to try a couple. Okay, not many. I want you to do page 267. Let's do 2 to 12 even. Why not? 6 problems. All right, you try those. We'll get to them tomorrow, and then I'll give you a few more in class. All right, thanks for watching. Remember, this is 4.2, Part 1. Part 2 coming up in a bit.